The chronicle of the dinosaurs is written across 240 million years of stone and silence, beginning in the late Triassic period. The Earth then was an alien world, a single colossal landmass we call Pangaea, adrift in a primordial sea. It was a world of extremes, forged in the crucible of immense volcanic activity and climatic upheaval, a planet just beginning to recover from a cataclysmic mass extinction. Into this volatile landscape stepped the first archosaurs, the ruling reptiles from which both crocodiles and the first true dinosaurs would diverge. These earliest pioneers were not the titans of popular imagination. They were relatively small, bipedal creatures, their bodies engineered for speed and efficiency. Their true evolutionary advantage lay not in their size, but in the unique structure of their hips and the upright stance it allowed. This was a blueprint for dominance. Evidence increasingly suggests they were warm-blooded, active animals, perhaps even possessing complex social structures that set them apart from their reptilian cousins. Then came the Jurassic. The supercontinent began to fracture, its fragments drifting apart. The climate softened, growing humid and stable. A new, green world erupted in verdant jungles and vast fern prairies. This was the dynasty's golden age. The rilly forests they inhabited. Alongside them rose the great therap, where some lineages pursued immense size, while others perfected their senses, honing hearing and vision into lethal instruments. A delicate, brutal balance was struck between hunter and hunted, a biological tapestry woven over millions of years, long before the first human mind could conceive of it. Today, these creatures live on in film, in games, and in the hallowed, silent halls of museums. But behind every skeletal mount lies a more profound question. Where was this stone chronicle unearthed? In what remote corner of the globe did a human hand first brush the dirt from a Maniraptoran fossil the size of a man? Who drew a fossilized egg from the unyielding rock, or held the serrated tooth of a predator, an artifact from a world that had passed into myth? The answers lie not in chance, but in geology. The Earth speaks loudest in specific places, in vast deposits now known as dinosaur graveyards. These are not mere burial grounds, but snapshots of ancient catastrophe, a sudden flood that swept away a herd, a volcanic eruption that entombed an entire ecosystem in ash. Here, researchers are given a rare opportunity not just to assemble a single creature, but to resurrect a whole community, to understand the intricate relationships between predator, prey, and the victims of circumstance. Beneath the soil lies a hidden logic. Every fossil bed is a precise convergence of ancient climate, geography, shifting tectonic plates, and the slow, patient work of sedimentation. It is a story that could only be preserved where conditions were perfect, where bone could become stone. For in the silence of the rock, the earth retains its memory, waiting for the patient and the curious to listen to the echoes of a lost dominion. To unearth the secrets of the dinosaurs, we must first peel back the layers of the Earth itself, a vast geological tapestry woven over hundreds of millions of years. The story is not written in every stone. It is a tale told exclusively within the fine-grained pages of sedimentary rock. One does not find the titans of the Mesozoic encased in granite, nor entombed in the fiery fury of volcanic tuff. Their remains lie in a different kind of archive: the sandstones, the siltstones, the limestones, and the argillites. These are the rocks born not of fire, but of water and time. They are the hardened mud of ancient riverbeds, the settled dust of primordial lakes, the compressed floors of long-vanished deltas and lagoons. These environments were the perfect cradle for eternity. Here, a fallen giant would not be left to the elements, but would be quickly covered by a gentle shroud of silt or sand. This rapid burial was the first critical step. It sealed the body away from the world above, in a realm starved of oxygen. The less oxygen, the slower the inexorable march of decay. The flesh and sinew would vanish, but the framework, the mighty bones, stood a chance. In this silent, anoxic darkness, the slow miracle of fossilization could begin. Organic material was gradually replaced by minerals, molecule by molecule, turning bone into stone, preserving a perfect three-dimensional echo of life. But the right kind of stone is merely the tomb. To understand the life it once held, we must reconstruct the world that was. The climate of the Mesozoic era was a planet-wide fever dream. During the Jurassic period in particular, the Earth was a greenhouse, basking in a perpetual humid warmth far exceeding even the most tropical climes of today. There were no polar ice caps, no vast frozen wastes at the top and bottom of the world. The average global temperature was significantly higher, and the atmosphere was thick with carbon dioxide, at concentrations nearly 4 times our own. This created a staggering stability, a warm, wet world where life could flourish on an unimaginable scale. Landscapes we now know as barren were once paradises. Where today there is only the sand and wind of the Gobi Desert, there once existed a vibrant Mesozoic savanna. During the late Cretaceous, this was a network of meadows and dune-fed lakes, nourished by seasonal rains. It was a perfect stage for the grand drama of life, supporting colossal herds of herbivores and the formidable predators that stalked. Yet even this world of verdant plains was not fixed. It was adrift on a sea of molten rock. The third critical factor in this great paleontological lottery is the slow, inexorable dance of plate tectonics. Over the last 200 million years, the supercontinent of Pangaea fractured, and its pieces began their long journey apart. Continents drifted, mountain ranges buckled and rose, and new oceans were born. In the violence of this planetary reshaping, countless layers of history were crushed, melted, or driven deep into the Earth's mantle, their secrets lost forever. But in this grand geological lottery, some regions were spared. The North American platform, for instance, has remained remarkably stable. It has not suffered the extreme deformations that erased the past elsewhere. Here, the sedimentary layers from the Cretaceous period lie relatively flat and undisturbed, a vast, accessible library whose volumes are filled with the remains of dinosaurs. A similar story, though with a violent twist, unfolds in the ancient beds of China's Liaoning province. Here, tectonic activity was moderate, but it was accompanied by frequent volcanic eruptions. What could have been an engine of destruction proved to be a blessing in disguise for posterity. Enormous clouds of fine ash rained down, rapidly burying entire ecosystems. This ash created a near instantaneous seal, capturing small feathered dinosaurs and other delicate creatures with such fidelity that even the impressions of their plumage remain. These volcanic interludes acted as a flash freeze of geologic time, preserving a lost world with breathtaking clarity. Finally, after the sediment, the climate, and the tectonic luck have all aligned, one last layer must be accounted for: us. The bones may lie waiting for eons, silent testaments to a lost world, but they do not reveal themselves. They must be found. The map of major dinosaur discoveries is therefore also a map of human endeavor. It points to nations with the resources, the technology, the academic traditions, and the political stability to mount decades-long expeditions into harsh and remote territories. Every fossil unearthed is therefore a confluence of impossibilities. It is the story of a creature that died in the right place, was buried at the right time, and rested in a piece of the Earth's crust that survived the ravages of deep time, only to be exposed, millions of years later, at the precise moment when another species had evolved the curiosity and the means to find it. It is a message in a bottle, cast into an ocean of time, waiting for the one species capable of reading its astonishing tale. A formidable infrastructure of scientific institutions, universities, and museums. A systemic commitment, both public and private, that fuels relentless inquiry. Researchers across these leading nations actively collaborate, their discoveries flowing seamlessly into the protected archives of museum and research collections. It is this combination, the regularity, the depth, the methodical approach, that generates the staggering statistics of discovery. But why these specific places? because here, a perfect confluence of circumstances occurred. Ancient rivers laid down blankets of soft silt, entombing the dead with gentle finality. A warm climate nurtured life, and a tectonic calm preserved its passing. And now, in our time, the final crucial element is added. Generations of human beings, willing to brush away the pages of geologic time, grain by patient grain, for decades on end. It might seem, then, that the age of dinosaurs was a drama played out on a few fortunate stages on Earth. But to look deeper is to understand a more profound truth. These were truly global creatures. Their remains have been unearthed on every modern continent, without a single acceptory buried beneath our feet. Asia has become a veritable treasure trove in recent decades. Mongolia, and specifically the vast wind-scoured expanse of the Gobi Desert, has gifted science with entire nests of eggs, their embryonic contents still visible. It has yielded perfectly articulated theropods, and even scenes from life frozen in time. One fossil, a legend in its field, captures a predator locked in a death grip with a protoceratops, a final violent tableau immortalized by a collapsing sand dune. Meanwhile, China, particularly the Liaoning province, became the epicenter of a paleontological revolution. Here, the discovery of feathered dinosaurs confirmed the long-theorized transition from terrestrial theropods to the birds that fill our skies. The preservation is miraculous, revealing imprints of soft tissue, the delicate architecture of feathers, and even the ghostly traces of pigment that once gave these creatures their color. North America represents a foundational chapter in this story, one of the first and most intensely explored theaters of discovery. Hundreds of species have been named from its soil, including such iconic titans as Triceratops, Tyrannosaurus, and Ankylosaurus. The territory stretching from Montana to Alberta is a vast graveyard, the remnants of ancient river systems where mass burials were a regular occurrence. American paleontologists began this work in the 19th century, and their successors continue to uncover new species almost every year. Journeying south, we reach South America and the windswept plains of Patagonia, a land of giants. It was here that the bones of the largest known land animals were found, capacity of museums, and the logic of ancient arcs. Yet South America's significance also runs deeper, back to the very dawn of the dinosaurs. It is here that we find some of the oldest known forms, such as Eoraptor, a primitive, lightweight predator from the late Triassic. These fossils are a precious window into the humble beginnings of a dynasty that would one day rule the world. Africa, a continent whose paleontological story is still rapidly unfolding, has already produced discoveries of immense importance. From the sands of Egypt and Morocco to the heart of Niger, the Earth has relinquished the bones of Spinosaurus, the colossal riverine hunter, and the shark-toothed Carcharodontosaurus. The Sahara, now a hyper-arid desert, was once a lush, fertile plain, and the Boothern supercontinents collided, making it a crucial nexus for understanding the global migration of these incredible animals. And then there is Europe, paleontologically quieter perhaps, but its contributions are foundational. It was here that the very concept of the dinosaur began to take shape with early discoveries in England and Belgium. It was in the fine-grained limestone of Germany that Archaeopteryx, the exquisite link between reptile and bird, was found. Each fossil, whether a colossal femur from Patagonia or a single feathered quill from China, is a word in a planetary epic. The bones tell a story not of isolated pockets of life, but of a single interconnected biosphere, a planet that belonged entirely to them. They remind us that the ground beneath our cities is not just rock and soil, but a library of lost worlds. And we, the latecomers to this planet, are only just beginning to learn how to read its pages. The story of their rediscovery begins not in some remote desert, but in the rolling hills of early 19th century England. Here, the first scientifically recognized dinosaur bones were unearthed, sparking a revolution in human thought. It was here that the very name was conceived, Dinosauria, the terrible lizards. From these initial English finds, the trail of evidence spread across the continent. Germany would offer the world one of its most precious fossils, Archaeopteryx, a creature seemingly caught between two worlds. With the feathers of a bird, but the teeth and claws of a reptile, it was a Rosetta Stone of evolution, a tangible link between the earthbound dinosaurs and the masters of the sky. As paleontologists fanned out, the map of this ancient world grew richer. France, Portugal, Romania, each yielded its own chapter, revealing the bones of both terrestrial giants and the great marine reptiles that patrolled the prehistoric seas. These discoveries painted a picture of a Europe utterly alien to our own. During the Cretaceous period, it was not a solid landmass, but a vast archipelago of islands separated by shallow, warm waters. This unique geography acted as an evolutionary laboratory. On these isolated islands, the leviathans of the mainland were scaled down. Here, we find the remains of dwarf dinosaurs, miniature titans perfectly adapted to the limited resources of their island ecosystems, a stark demonstration of evolution's pragmatic power. Across the immense expanse of Russia, a different story is etched in stone. In the Trans-Baikal region of Chita, the Earth has surrendered the bones of predatory theropods that stalked these lands during the Cretaceous. Further east, in the Amur Oblast near the village of Kundur, vast bone beds have revealed entire graveyards of hadrosaurs, the so-called duck-billed dinosaurs, their intricate skeletons preserved with astonishing fidelity. Even the Crimean Peninsula bears their mark, not in bone, but in ghostly footprints left in ancient mud, hardened to stone. In the heart of Siberia, the Kemerovo region has yielded fragments of colossal sauropods, while along the ancient seaway of the Volga River, the remains of plesiosaurs and ichthyosaurs tell of the marine leviathans who shared the planet with their terrestrial cousins. For generations, Australia was considered a lost continent in the age of reptiles, its fossil record strangely silent. But recent decades have shattered this illusion. In Queensland and Victoria, the rock has begun to speak, revealing a unique fauna of both herbivores and formidable predators, including the fearsome megaraptors. The continent's long isolation fostered a distinct evolutionary path, yet these fossils also tell a deeper story, a story of connection, of a time before the Great Rifting, when Australia was fused with Antarctica and South America in the colossal southern supercontinent of Gondwana. But perhaps the most profound testament to their dominion lies buried beneath kilometers of ice, at the very bottom of the world, Antarctica. Today, it is a continent of inhuman cold and desolation. Yet, during the Mesozoic Era, it was a green and vibrant part of Gondwana, a realm of temperate forests experiencing months of continuous polar twilight. On James Ross Island, braving the most extreme conditions on Earth, scientists have unearthed the definitive proof: the fossilized remains of dinosaurs, including a megafaunal hadrosaur. These finds, though rare and agonizingly difficult to acquire, are invaluable. They prove that the dinosaurs were not creatures confined to the tropics. They were masters of adaptation, capable of thriving even in the challenging polar regions. Their reign was absolute, their dominion planetary. How could a single family of life conquer lands now separated by impassable oceans? The answer lies not in the creatures themselves, but in the very ground beneath their feet. Our modern map, with its familiar continental shapes and vast blue divides, is a fleeting illusion, a single snapshot in the deep album of geologic time. The truth is that the Earth, this stone vessel of time, has never been static. It breathes, it shifts. Continents drift in a slow, inexorable dance, colliding, merging, and tearing apart over eons. The world the dinosaurs knew was a world in motion. The footprints they left on a sandy shore in one epoch are now found on a mountain peak in another, on a continent thousands of miles from where it began. They were not merely inhabitants of the planet, they were passengers on its epic, transformative journey, their fossilized remains a permanent signature woven into the very fabric of our world's geological biography. Within the dark, stratified archives of the Earth, geologists and paleontologists decipher a story written in stone, a chronicle of mergers and fractures, of colossal continental ballets and the birth of new worlds. With reverent persistence, they reconstruct one of the most profound sagas in our planet's history, the dissolution of Pangea. This was the one world, the single supercontinent, that once gathered nearly all of the Earth's dry land into a solitary, magnificent mass. Its name, meaning all Earth, was no accident. It is believed to have coalesced some 335 million years ago, the culmination of a long cycle of continental convergence in the late Paleozoic era. Majestic and sprawling, it stretched from the high northern latitudes to the southern pole, a world stitched into a single tapestry. The land masses we now know as North and South America, Europe, Africa, Asia, Australia, and Antarctica were all locked together in its primordial architecture. Within its embrace lay the planet's most ancient mountain ranges, vast forests of giant ferns, and powerful meandering rivers. And through this landscape moved a strange and vibrant pulse of life, already diverse and complex, flourishing even beneath the ominous skies of the Permian period. But as with all great unions, the unity of Pangea was destined to be temporary. Deep within the Earth's mantle, that searing, viscous ocean of rock where convective currents churn with unimaginable force, powers were gathering. These are forces indifferent to civilizations, to life itself, the slow, inexorable heat of the planet's molten heart. Approximately 175 million years ago, as the Jurassic period dawned, a process began, imperceptible on a human timescale, yet utterly world-altering. The great supercontinent began to break. The first fissures appeared along the seams, the tectonic boundaries where millennia of accumulated stress finally found release. Along these lines, the crust heaved and subsided, carving immense rift valleys into the landscape. From the planet's depths, basaltic lavas poured forth, flooding millions of square kilometers and creating the vast igneous provinces that serve as geologic tombstones for this cataclysmic era. Under the relentless assault of these internal forces, Pangea fractured first into two colossal children, Laurasia to the north and Gondwana to the south. Laurasia held the seeds of North America and Eurasia. Gondwana contained the future of South America, Africa, Antarctica, Australia, and the Indian subcontinent. These were no longer one Pangea, but not yet the 7 continents of our modern world. Over tens of millions of years, the fragmentation continued. The new continents began to drift apart upon the lithosphere million years ago. South America began to tear away from Africa, a violent separation that gave birth to a new ocean, a narrow, volcanically active sea that would one day become the vast Atlantic. At nearly the same time, the Indian subcontinent, having broken free from the eastern edge of Gondwana, began an astonishingly rapid journey north. It raced across the ancient Tethys Ocean at a speed of up to 20 centimeters per year, a tectonic sprinter on a collision course with Asia nearly 70 million years in the future. Meanwhile, Australia peeled away from Antarctica, beginning a slow, solitary voyage into the southern waters. Soon after, Antarctica itself began its own drift, a journey that would carry it to the South Pole, where it was fated to be locked in an eternity of ice and isolation. Against this backdrop of colossal geodynamic upheaval, life was forced to adapt and evolve. The Great Continental Sundering was also a great biological divergence. Creatures once able to roam a single world found themselves marooned on immense continental rafts, set on evolutionary paths that would forever distinguish them from their distant cousins. The world we know today, its distinct realms of life, its oceans, its very climate, was forged in the heart of this planetary disintegration. The dance of the continents is not over. The forces that tore Pangea asunder are still at work, silently reshaping the map. The Earth remains a work in progress. For the paleontological eye, there is no canvas more arresting than the one painted by the Mesozoic, the age of reptiles. In the late Triassic, as the world's landmasses lay fused into the single supercontinent of Pangea, the first dinosaurs emerged. They were pioneers in a unified world, their spread across the globe facilitated by an unbroken expanse of Earth. By the time the Great Sundering began, they had already confidently colonized nearly every terrestrial biome. Great theropods and colossal sauropods traversed endless plains, their migrations unhindered by oceans. Their bones, unearthed today on every continent from the frozen wastes of Antarctica to the arid heart of Africa, are a silent testament to this forgotten unity. The very same species could have stalked prey in what would become South America and roamed the fern prairies of ancient Asia until the planet itself began to stir and geography began to dictate new, inexorable rules. With the dawn of the Jurassic period, the world began to fracture. The slow, titanic pull of tectonic forces started to tear Pangaea apart. As new seas bled into the rifts, they rewrote the climate of the entire planet. New ocean currents were born, forging novel weather patterns, creating vast, humid regions where deserts once stood, and summoning powerful monsoons to drench the land. The single, sprawling biome of Pangaea was shattered into a mosaic of new worlds. In this fragmentation, evolution found its accelerator. Isolation became the crucible of creation, giving rise to endemism, life forms unique to their own isolated lands. Where uniform dynasties once reigned, a legion of new species, each exquisitely adapted to its local stage, began to appear. The Jurassic saw an explosion of life. The Earth trembled beneath the weight of Diplodocus and Apatosaurus. In the dense cycad forests, the roar of the great Allosaurus echoed, while high above, pterosaurs carved silent arcs across the skies of the ancient seas. This diversification reached its zenith in the Cretaceous. The continents drifted further, each one a distinct evolutionary laboratory. This was the time of the armored ankylosaurs, the horned ceratopsians, and the undisputed tyrant king, Tyrannosaurus. Duck-billed hadrosaurs filled the wetlands, and 1,000 other forms, each more specialized than the last, populated these new, isolated continents. And yet, for all their power and diversity, the dinosaurs remained children of their time, an age defined by the slow, grinding certainty of tectonic change. As the continents drifted into their modern configurations, the climate grew harsher, the flora more complex. The world of the late Cretaceous, some 66 million years ago, was almost recognizable to our eyes. South America had broken free from Africa. The Indian subcontinent was on a collision course with Asia. North America had assumed its familiar triangular shape. It was into this transformed world that a cataclysm struck, closing the final chapter on their reign, leaving behind only ash and scars in the geological strata. But the geological forces that shaped their destiny did not die with them. The breakup of Pangaea never truly ended. It is a process that continues today, written in the widening of the Red Sea, the slow tearing of the East African Rift Valley, and the relentless expansion of the Atlantic Ocean. The continents are still adrift upon the mantle, and they will continue their silent voyage for as long as the Earth itself remains a living world. Looking back upon this immense saga, we see the dinosaurs not merely as creatures of a bygone era, but as a mirror to the planet itself. Their story reflects the most profound and complex processes of existence, the awesome power of Earth's tectonics, the subtle dance of a changing climate, and the unbreakable, intricate bond between life and the world it inhabits. For millions of years, they reigned supreme. Giants of flesh and bone, they were the undisputed masters of adaptation, their forms shaped by a world we can now only imagine. But even their dominion was finite, a chapter in a much larger story, and in the end, they gave way to new dynasties of life. The planet itself continues its slow, inexorable dance. Far into the future, after hundreds of millions of years have passed, the titanic forces of geology will once again gather the scattered lands. A new supercontinent will rise, a world reborn, what geophysicists today call Pangaea Ultima, or perhaps Amasia. And on that distant shore of time, the archaeologists of the future may arrive. They might be beings from beneath other stars, their tentacled hands gently brushing away the dust of eons. Gazing into the fossilized bones of the creatures that live today, they will excavate our past with the same awe and reverence we hold for the titans that came before us, trying to understand how this earth changed when we were still here.